A rational number is a number that can be written as a simple fraction. The decimal expansion of a rational number either terminates or repeats. A repeating decimal, when it repeats, is written using a bar line. A bar line appears over the digits that repeat. So for example, 0.3, the only digit repeating is 3. Here, 0.12 repeating, the 1, 2, 1, 2, 1, 2 will repeat. And 1.83, here the bar is only over the 3, so the 1 and the 8 will appear, but then only the 3 will repeat. Since a repeating decimal is a rational number, it can be written as a fraction. But how do we do that? Try in a group to write 0.15 repeating as a fraction. Think of our rules of how we converted fractions to a decimal and see if it will work. Hopefully in your group you're having different ideas, but we can come up with some simple steps that we can always follow to convert. We're going to set x equal to the repeating decimal, determine how many digits repeat, multiply both sides of the equation by 10 to that power, rewrite the equation in partially expanded form, replace the repeating decimal with x, solve the two-step equation, and then simplify. These 7 steps will get you to convert a decimal to a fraction, especially when it's repeating. Let's take a look at 2 examples where it's already done for us, starting with that 0.15 repeating. So here we're setting x equal to the repeating decimal. We need to determine how many digits repeat, and here we can see that 2 of them, the 1 and the 5. So that means we're going to multiply both sides to the equation by 10 to that power, or 10 squared. And 10 squared is just 100. We're then going to rewrite the equation. Well, actually, first, when we multiply by 100, that brings us to 15.1515 repeating. We're then going to rewrite that equation, the 15.151515, in partially expanded form, giving us 15 plus 0.1515. And then we'll replace the repeating decimal left over here with x. So this became an x. We're then going to solve this equation for x. We would subtract x to get 99x and then divide by 99. Simplify, we can have 15 over 99, or finally 5 over 33. So 0.15 repeating is the same as 5 over 33. Looking at a second example to see it will work again, we can look at 0.4 repeating. First, let's set x equal to the repeating decimal. Determine how many digits repeat. Here we can see only the 4 repeats. That's only 1 digit. So we're going to multiply both sides of that equation by 10 to the first power, or 10, which gives us 4.444 repeating on the right side of the equation. We're then going to write that in partially expanded form and get rid of the decimal or move it away from the whole number. So 4 plus 0.444 repeating. Replace that decimal with the x and solve the two-step equation by subtracting x and dividing by 9. Simplify, 4 over 9 is already reduced, so 4 over 9 would be our answer to the question 0.4 repeating. Let's take a minute and do these on our own without the steps there. Here we need to set our repeating decimal. Here we have 0.5050, set it to x. We can see that the 5 and the 0 are repeating, so that's 2 digits. So we're going to multiply both sides by 10 squared. When we multiply 10 squared is the same thing as 100. And we can then rewrite the right side by actually multiplying by 100. That will give us 50 0.5050 repeating. We can then write this in partially expanded form by separating the decimal, giving us 50 plus 0.5050 repeating. And replace that repeating part with an x. And solve the two-step equation. We'll subtract x from both sides. That will give us, I'll continue over here. That will give us 100 minus 1 will give us 99x equals 50. Divide by 99, both sides, to give us a fraction of 50 over 99. So that repeating decimal gives us that fraction, 50 over 99. Let's see it once more. Here we have 0.27. Let's set that equal to x. So 27 repeating. We can see those two digits, the 2 and the 7, are repeating. So again, I'm going to multiply by 10 squared, both sides, since that's how many digits we're repeating. 10 squared is the same thing as 100. And when we actually multiply out the right side, that gives us 27.27272727 repeating. We can then write it in partially expanded form, separating that repeating decimal. So it'll be 27 plus 0.2727 repeating. Replace that decimal with an x. So 27 plus x. Subtract the x and come over here to the top. 100 minus 1 would give us 99x equals 27. Divide by 99, and we would have x equals 27 over 99, which we can reduce if we divide both by 9 as 3 over 11. So 3 over 11 is the same as 0.27 repeating. We've now officially converted our repeating decimals into fractions using those key 7 steps.